We are live. Okay, so today is 8/29. Wow, it's still August. Isn't it a bummer?
No.
What are we doing in school? 8/29. Okay, so remember what this graph looks like? And I'm going to use two different colors, okay? So this is my regular V. My absolute value graph looks like that. Correct. There's my absolute value, right? And then what I'm going to do is I'm going to move it. I'm actually going to move it. So I'm going to take the entire graph and we're going to move it back 3 or to the left, same thing as the left, right? And then we're going to move it down 2. So the whole thing, the entire graph is going to go back 3, down 2. So for me, let's just move the vertex, right? If this is the vertex, we'll go down 1, 2, 3, and down 1, 2. So we took the whole thing and we just move it back 3, opposite, right? It's got to be the opposite. And again, I'll say it again. If I think about this, what number would zero this out? What number? -3, right? And that's why it's the opposite, because it zeroes it out and brings it all the way down to the vertex, okay?
But wouldn't it only be with absolute value?
Well, with everything it's going to work. It's a little tricky with a line, with a straight line. I mean, yeah, it's easier with a vertex, with a absolute and a parabola. But it works for everything, but it's easier with those two because they have vertexes, right?
Okay.
Good, very good question. Okay, now, in fact, let's answer this, okay? So I've got y equals x. We know that looks like this. Austin, this is going to answer your question, I think. Okay, you guys see y equals x? Okay, because it's a 1 over 1x plus 0. It's a straight line. It's linear, right? It's linear. Right, so start at 0, up 1 over 1. And now let's move this. So here's your question, right? So we're going to move the whole line, Austin. We're going to move it to the right 1, and we're going to move it up 5, okay? So there's no vertex, right? So let's pick any point. Take any point on the line, let's move it. Well, obviously the easiest point is at the 0, 0. You guys agree with that? So we're going to move the whole line. So the easiest way is just pick any point on the line, because we're going to move the whole line. I'm just going to pick this point, okay? Because I could pick any of them, but I'll pick this one. And so to the right 1, 1, and then up 1, 2, 3, 4, 5, and there it is, right? Okay, 3. Am I going too fast? Am I okay? All right, slide up. So 3, x squared. Okay, so I know what that's a parabola, right? 0 squared, 1 squared, 2 squared, 3 squared, right? So I know that it's going to go 1, 1, 2, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's way up here. It is symmetrical, right? It is symmetrical. So the parent function looks like this, okay? Now, what are we going to do? Well, it's definitely going to be upside down, or reflection over x-axis, okay? I know that for sure because of the negative, okay? I know also that it's going to be twice as tall, or it's a stretch. It's a vertical stretch, okay? So it's a vertical stretch. And I'm also going to move it up 4, okay? And I'm going to then translate up 4. Translate up 4. Okay, how am I doing? So I'm going to do 3 things. We're going to reflect it over the x-axis, so it's going to be like this. We're going to make it twice as tall, but since it's going upside down, it's twice as tall going down. And we're going to move it up 4. So I'm going to do that. Let's move it up 4. 1, 2, 3, 4. I know it's going to wind up there, right? It's going to wind up to plus 4 because of that. It's going to be upside down because of the negative. But instead of going 1, 1, 1, 1, I'm going to go twice as tall. 1, 1, I'm going to 1, twice as tall. So 2, 1, 2, 3, 4. I'm going to be twice as tall instead of 2, 1, 2, 3, 4. I'll go 5, 6, 7, 8. And I'll go 3, 9, but 3, 8, that'd be off my paper, right? So, and I know it's symmetrical, so I can just reflect my points there. And this graph looks like this, okay? Thumbs up? We had 3 different things. We had a reflection, we had a vertical stretch, and we had a translation up 4. Okay? Turn the page. Am I okay? All right, stop me if you get confused, okay? Now 4. This is a square root graph. So a square root graph looks like this, okay? Square root graph. So put your pencil right at 0, 0. Put a dot. Square root of 0 is 0, correct? Go over 1. See, put your pencil here. Go over 1. What's the square root of 1?
1.
Good. So go up 1. Go over to 2. Now the square root of 2 is an ugly number. It's 1.41 blah, 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 blah. I could put that on there, but I'm not going to, okay? Go over to 3. What's the square root of 3? Yeah, it's about 1.73 blah, blah. I'm not going to put that on there. But I will go to 4, because what's the square root of 4? 2. Okay, and what would be the next nice number? 9, right? Because the square root of 9 is 3. So I'd go, there's a bunch of decimal ones in between, but I would really go 4, 5, 6, 7, 8, 9, and I go to 3, right? What's the square root of negative 1? Can't do it. What's the square root of negative 2? Can't do it. So the graph doesn't have anything back here, right? Okay, now I've got this negative on the inside, and that means I'm going to reflect it over the y-axis because all the x's become negative. So if all the x's become negative, the graph goes that way. Does that make sense? So there it is. We're just going to go and do the exact same graph, but 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3. So it looks like that. How's that? Make sense? Okay. Number 5. X cubed. All right. Put your pencil right there. Everybody put your pencil on 0, 0, okay? So you ready? Easy. 0 times 0 times 0.
0.
Or 0 cubed is 0, all right? Put your pencil right there on 1. 1 times 1 times 1. Don't say 3. 1 times 1 times 1 is?
1.
Or 1 cubed is 1, right? Put your pencil right there on 2.
8.
There you go. 2 times 2 times 2, or 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. Nice job, okay? Now, put your pencil right there on negative 1. What's negative 1 times negative 1 times negative 1? Negative 1, because a negative, negative, negative is negative 1. Okay, put your pencil right there, negative 2. It's negative 2 times negative 2 times negative 2. Negative 8, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, okay? So the cubic function, the parent function looks like this, okay? There's my x cubed, okay? Now, what are we going to do? We're going to move this graph. We're going to move it to the right 3 and up 2. Austin, here's your question again. It's a good question. It's a really good question. So there's no bottom point, but is there one particular point that would make it easy to move? Yeah, probably that one right there, okay? That's called an inflection point, okay? You don't need to know that until you get to calculus, but that's called an inflection point, okay? So let's move the inflection point right to 3. 1, 2, 3, and then up 1, 2. So there's my inflection point, and now I'm going to do the same graph. Just take the entire graph, same shape, don't change shape, and just move it. So I'm going to go my 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, negative 1, 1, negative 2, 1, 2, 3, 5, 6, 7, 8, and there it is. Okay. Thumbs up. Okay, I see one thumb up. Okay, sideways is okay. That's okay. 2, 3, thumbs up, good. Now, if this is a cube, graph, then a cube root should be similar in shape, right? Should be, okay? So let's do the same thing, okay? Put your pencil right there in the middle, okay? So, what times what times what makes 0? So the cube root of 0 is 0, okay? Okay. what times what times what makes 1?
1.
So the cube root of 1 is 1, okay? Let's move all the way to 8. All the way to 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm right here on the x value, okay? So what times what makes 8? So if I put 8 into here for x, if I put 8 right here for x, the cube root of 8 is 2, right? Celeste, you have a question? No. Okay. So just the opposite. -1, the cube root of -1 is -1. 1, 2, 3, 4, 5, 6, 7, 8. Cube root of -8 is -2. And here's your cube root graph, right? We saw that yesterday a little bit also, okay? Now, let's move it. How are we going to move it? We're going to move it to the left, 2, and down 5. Okay, so we're going to move the whole entire graph, but one point in particular looks like the easiest to move it, right? So if I move the one point, which is the inflection point again, if I move the inflection point, then it makes it easier with the whole thing. So let's move it left 2, 1, 2, and down 1, 2, 3, 4, 5. So it's off the graph, life goes on, and it's going to look something like that. How's that? Okay, not too bad.